Welcome students, this is Chandan Singh Negi. Student, today we will discuss about the graphical representations. That means the solution of two linear equations are consistent or inconsistent solutions. For that, let we have two linear equations, that is a1x plus b1y plus c1 is equal to 0, and second linear equation is a2x plus b2y plus c2 is equal to 0. This is the linear equation 1 and linear equation 2. If we draw the graph of these two linear equations, we will get the straight line on the Cartesian plane. There are some cases like without the solution of these two linear equations, if we afraid this divide these coefficients, these are called coefficient. This is a1 coefficients of y, b1 coefficient, and c1 is constant term. This is a2 coefficient of x, b2 coefficient of y, and c2 is the constant term. Now case number 1, when these two lines are intersect to each other, when these lines are intersecting, that is called consistent solutions, and there is only one unique solution of these two equations when they are consistent or intersecting. The case number 1, when a1 upon a2 is not equal to b1 upon b2, it maybe is equal to c1 upon c2, but the must condition is a1 upon a2 must not be equal to b1 upon b2. Then these lines are called intersecting lines, and there is a unique solution of that. That is a unique solution. That is means the only one answer which is same for both the equations, unique solution. And such type of solutions is called consistent solution. Consistent solution, right? The condition number 2, when a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2, then these two lines are parallel. These lines are called parallel lines. These lines are called parallel lines, and there is no common solution. So no common solution. Common solution means both the solution will satisfy both the equations. No common solution, and such type of solution is called inconsistence. Inconsistence. The case number 3, if a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then these lines are called coincidents. Coincident lines. Then there are infinite number of same solution. The infinite solution, that is consistence, but there is no unique solution. That means there are infinite number of solutions of both the equations which satisfy both the equations. So such type of solution is called consistence but dependent consistence. Dependent consistence. This is a condition of dependent consistency, right? Dependent consistency, that means if the one solutions, if I put the one value of x, then always we will get the value of y. Then that means if we solve the one equation number 1, and we will get the same solution of the equation number 2. That such type of solution is called dependent consistency. See examples of 1. Like if 2x plus 3y plus 7 is equal to 0, and second equation is 3x plus 6y minus 1 is equal to 0. So this is a1, this is b1, a2, this is b2. This is a1 upon a2 is equal to 2 upon 3. If you look, this one b1 upon b2 is equal to 3 upon 6 is equal to 1 by 2. So here a1 upon a2 is not equal to b1 upon b2. So that such type of equations is called, that is, intersecting. And intersecting solutions, that means consistence, and that is one unique solution of that, right? Case number 2, example number 2, if we have 3x plus 4y plus 10 is equal to 0, and second is 9x plus 12y plus 5 is equal to 0. Now again this is a1, b1, c1, a2, b2 and c2. Let's check. This is a1 upon a2 is equal to 3 upon 9, this is 1 by 3, and b1 upon b2 is equal to 4 upon 12, that is equal to again 1 by 3, and c1 upon c2 is equal to 10 upon 5 is 2 is equal to 2. This implies that a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. That means these are the parallel lines and this is inconsistence. So there is no common solution of that. That means we cannot solve these two equations for the common solution. And case number 3, that is example, if we have 5x plus 6y plus 4 is equal to 0, and second is 10x plus 12y plus 8 is equal to 0. Again this is 5, this is 6, a1, a2, and this is a1, b1, and this is c1, and this is a2, b2 and c2. Let's check it. This is a1 upon a2 is equal to 5 by 10, this is 1 by 2. Now check, this is b1 upon b2 is equal to 6 by 12 is equal to 1 by 2, and c1 upon c2 is equal to 4 by 8 is equal to 1 by 2. Now this implies that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So this implies that coincident line, this is coincident lines, that is consistent but dependent. Now if we solve one equations for any value of independent variable, that is x, we will get the dependent variable, and that will be the solution of the second one also. Just recapitulate this one. We have two equations, and if a1 upon a2 is not equal to b1 upon b2, that is a consistent solution, there is a unique solution, and lines are intersecting. If a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, that are parallel lines, no common solution, inconsistent solutions. And the third condition, if a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then these lines are coincident lines. There are infinite solutions of both. If we solve one equation, that the solution will be the other also, and that is called dependent consistency. Thank you, students.